All right, everyone, welcome. Today, we're taking a deep dive into Kubernetes. You're here because you want to understand container orchestration, right?
Yeah,
Well, you've come to the perfect place.
Yeah, it's definitely become a hot topic.
Absolutely,
There's a reason everyone's talking about Kubernetes for deploying and scaling applications these days.
for sure. So let's get right to it. What is Kubernetes really doing for us? Like, what's the big picture here?
Well, at its core, Kubernetes is all about automation.
Hmm, okay,
Imagine, think of it like a conductor of an orchestra, right?
okay.
Except instead of musicians, we're working with containerized applications
Ah, got
and
you.
Kubernetes making sure everything is running smoothly, you
Yeah,
know,
right.
like all playing in sync, everything's at the right time, the right level.
Okay, that's a helpful image. But you mentioned containerized applications, and that's a term we hear a lot. What does that actually mean?
Right, so picture this.
Yeah.
Each of your applications is packaged neatly in its own little box, a container. And this container has everything the application needs to run, all bundled up together.
Hmm.
Kubernetes takes those containers and manages their deployment, scaling, and overall management across a whole cluster of machines.
So instead of manually setting up servers and worrying about where applications are running,
Exact.
Kubernetes handles all that behind the scenes.
Yes, exactly. And that's just the beginning.
Wow.
It also handles things like resource allocation, making sure each application gets enough power and memory.
Uh-huh.
And it has this cool thing called self-healing, meaning it can automatically restart containers if they fail.
Oh, that's interesting. Okay, I'm starting to see why this is such a big deal. So how does it actually work? Like, what are the key pieces of this Kubernetes system?
Okay, let's break it down.
Great.
At the center of every Kubernetes cluster, you have the master node.
Okay.
This is like the brain of the operation, responsible for managing the entire cluster.
Yeah.
It schedules and orchestrates the deployment of those containerized applications.
So if the master node is the brain, what about the actual machines where the applications are running?
Right, those are the worker nodes. They're the workhorses, providing the computing resources and running the containers.
Mm,
And you can have multiple worker nodes in a cluster, which helps to distribute the workload and provide redundancy.
gotcha. So master node is in charge, worker nodes do the heavy lifting. But what about the applications themselves? How do they fit into this structure?
Okay, that's where pods come in.
Pods.
Yeah, a pod is the smallest deployable unit in Kubernetes.
Okay.
Think of it as a container or a group of containers that logically go together.
Mm,
They share resources and networking and are always deployed together on the same worker node.
interesting. So if we picture a real world application, let's say an e-commerce website, how would that be structured using these Kubernetes components?
Sure, let's use your e-commerce site as an example.
Okay.
You might have separate containers for things like the web server, the database, maybe your recommendation engine.
Right.
These containers would be grouped together into pods, and Kubernetes would deploy these pods across the worker nodes, making sure they can all communicate with each other.
Makes sense. But even with all these containers neatly organized into pods, we still need a way to access them, right?
Absolutely, and that's where services come in.
Services.
Yeah, a service provides a stable endpoint for accessing a group of pods, even if the individual pods are moved around or replaced.
Okay.
Think of it as an internal load balancer, distributing traffic across the pods.
So even if a pod fails and gets replaced,
Right.
the service ensures our e-commerce site remains accessible.
Exactly.
Wow.
Services abstract away the underlying pod instances, giving you a consistent point of access for your application.
This is starting to paint a clearer picture. We have the master node orchestrating everything, worker nodes running the pods, and services providing a way to access those pods. But how do we actually get these applications deployed and running in the first place?
That's where deployments come in.
Deploy.
Yeah, think of a deployment as a blueprint. It's like a set of instructions for how your application should be deployed and managed on Kubernetes.
Okay.
You specify things like how many replicas of a pod you want running, the container image to use, any specific configuration settings.
Hmm.
Kubernetes then takes that blueprint and, well, makes it happen. Brings your application to life within the cluster.
So it's like we're giving Kubernetes the instructions and it just takes care of the building process.
Exactly.
Yeah.
And the cool thing about deployments is that they make updates and rollbacks really easy.
Oh, that's nice.
You can update your application by simply modifying the deployment configuration, and Kubernetes handles the process of rolling out the changes gracefully, so there's minimal downtime.
That's really helpful, especially for applications that need frequent updates. But how does Kubernetes make sure those pods are always running and, well, healthy?
Right, so Kubernetes uses something called probes for that. Yeah, they keep a close eye on the health of your pods. There are two main types. liveness probes and readiness probes.
Liveness probes and readiness probes. What's the difference?
Well, a liveness probe checks if the main process in a pod is running. It's a quick heartbeat check, basically.
Yeah.
If the liveness probe fails, Kubernetes knows there's something wrong with the pod, and it'll try to fix it by restarting the pod.
So it's like a safety net, making sure a crashed pod is brought back to life.
Yeah, exactly.
What about these readiness probes then?
A readiness probe is a little more in-depth.
Okay.
It actually checks if the pod is ready to handle traffic. This is important because a pod might be running, but not yet ready to receive requests.
Right. Like a shop might be open, but still setting up.
Exactly. If a pod fails its readiness probe, Kubernetes will remove it from the service's load balancing pool until it's actually ready.
Okay, that makes sense. So Kubernetes is deploying our applications, monitoring their health, and making sure only healthy pods are receiving traffic. That's pretty impressive. But with potentially hundreds or even thousands of pods running, things could get a bit chaotic, right?
You're right. Managing a large Kubernetes cluster can get complex. So Kubernetes offers a feature called namespaces.
Namespaces, what are those?
Well, think of namespaces as virtual clusters within your main cluster.
Okay.
They let you divide your resources into logical groups based on things like teams or projects or even different environments.
So for our e-commerce website, we could have like a development namespace, a staging namespace, and a production namespace.
Exactly.
Hmm.
That way, developers can work in the development namespace without affecting staging or production.
Yeah.
This is a great way to keep things organized and isolated,
Right. Less chance of accidentally breaking something important. So we've talked about pods, services, deployments, namespaces. All these pieces seem to work together to make a reliable platform for our applications. But what about the network? How do all these pods communicate? And how does traffic from the outside world get to our applications?
Kubernetes has a very powerful networking model that ensures smooth communication between pods, whether they're on the same worker node or not. Each pod gets its own unique IP address, and pods can communicate with each other directly using those IP addresses as if they were on the same physical network.
So Kubernetes creates its own internal network then.
Precisely. And this internal network is separate from the outside world, which is good for security.
Okay, so we've got this internal network for the pods to talk to each other, but how does traffic from the outside world, like customers visiting our e-commerce website, reach our application pods?
That's where services come in again. Remember, a service gives you that stable endpoint to access a group of pods.
Right.
It acts as an entry point, routing requests to the right pods.
Gotcha. So services are like a gateway between the outside world and our internal Kubernetes network. Can we control that routing in a more granular way?
Absolutely. Kubernetes has something called ingress for more complex traffic routing.
Ingress?
Yeah.
What's that?
Think of ingress as a traffic manager that sits at the edge of your cluster and directs incoming traffic based on rules you define.
So like a receptionist who directs visitors to the right department.
Exactly. Ingress lets you define rules based on things like the host name, the path of the incoming request, even the type of traffic.
Okay.
So you can route traffic to different services based on whether the request is for the website, the API, or something else entirely.
So for our e-commerce site, we could use Ingress to send requests for, say, product images to a specific group of pods, while sending requests for customer data to a different, more secure group.
Exactly. Ingress gives you a lot of control over how traffic flows within your cluster. You can really optimize for things like performance, security, and scalability.
This is all starting to come together. It's a pretty complex system. We've got the master node, the worker nodes, the pods, the services, and now Ingress. It's like a well-coordinated team, each with its own specific role to play.
It is. Kubernetes is an incredibly versatile platform,
Yeah.
and it's even more powerful because of its extensibility.
Extensibility. What does that mean when we're talking about Kubernetes?
Well, it means that Kubernetes is designed to be adaptable. You can extend its functionality to meet your specific needs. You're not just stuck with the core features.
Oh, okay, but that sounds maybe a bit intimidating. How do you actually extend Kubernetes? Is that something only super techie people can do?
One of the most popular ways to extend Kubernetes is through operators.
Right, operators. We
Right.
talked about those a little earlier. Can you remind me what they are again?
Sure. Think of an operator as a specialized piece of software. It's like having a dedicated team of experts, but in software form.
Okay.
It knows how to deploy and manage a particular application on Kubernetes, like a database or a monitoring tool.
So if we go back to that e-commerce website, Could we have an operator that knows how to deploy and manage our database software?
Exactly. And then another one for the web server.
Right, right.
Exactly. And these operators can handle everything, from setting things up initially to scaling, backups, even disaster recovery.
Wow.
It takes care of those complex tasks so you can focus on building your application.
So instead of us having to figure out all the details of deploying and managing all these different services on Kubernetes,
Yeah,
we can just use these operators to do it for us. It's like having specialized help on call all the time.
that's a great way to think about it.
So where do we get these operators? Do we have to create them ourselves?
Not at all. There's a whole ecosystem of operators out there ready to use for all kinds of applications. You can find them in places like operatorhub.io. It's like a
Yeah.
central hub for Kubernetes operators.
So if we're using a common database, there's probably already an operator out there that we can use.
Most likely, yes.
Hmm.
And if you have something really specific, you can always develop your own operator.
Wow, that's amazing. This has been a fascinating look at Kubernetes, and I think our listeners will be able to take away a lot from this deep dive.
Yeah, I hope so.
We've covered the master node, worker nodes, pods, services, deployments, namespaces, ingress, even operators. It's a lot to take in.
It is a lot, but it's designed to work together seamlessly.
Any last advice for someone who might be a little overwhelmed by all of this?
Well, I would say just get started. Don't be afraid to jump in and experiment with Kubernetes. There are lots of resources online, and there's a great community that can help. Start small, get your hands dirty, and don't worry too much about making mistakes. That's how you learn.
I love that.
Well,
There's really no substitute for just trying things out. Well, on that note, I think we've come to the end of our deep dive into the world of Kubernetes. Thanks so much for guiding us through it all.
it's been my pleasure. I love talking about Kubernetes.
And to all our listeners, thanks for joining us on this Kubernetes adventure. I hope you feel ready to start exploring this fascinating world. Until next time, happy Kubernetesing.